let me begin. I will begin with a word of prayer.
Do you like pho?
Like what?
Do you like pho?
Pho?
Like this one?
I don't like soup in general, so not really.
I feel like you'd like tomatoes.
But I do like the numbers 14 or 15 at Saigon Palace. Like they've got a combo thing. It's got like cold noodles and a bunch of different kinds of pork and stuff. It's not really ramen. It's like cold rice noodles or something. It's got some like pickled carrots and lettuce, some bean sprouts. It's pretty good.
That sounds like
That place is by the Calvary Chapel.
Oh yeah.
Over on Timberlake. Right. All right. I guess this is tolerable. But who does this? Like, I know it's not you guys.
There's a bunch of like adults and older adults.
Do they need to be this close to like see the board? Is that it? I mean, like, what's?
Yeah,
It helps me out.
All right. So if I spit on you, if I spit at you at any point, it's my apologies. But I did forewarn it. I will begin with a word of prayer. So. Dear Heavenly Father, we thank you for this day. I thank you again for these students, and thank you for the apparent lack of seafarers in this room. And help us to have a good class. Help us to glorify you what we do, and just to learn a little bit more math together, Lord. In your name I pray. Amen.
You don't like the seafarers?
Wait a minute. Oh, man. All right.
Why don't you like the seafarers? Seafarers
What?
is so fun.
Seafarer is fun.
Yeah.
What's that? Top Hat. Let's not speak of Top Hat. Oh, Top Hat. So are you? What? Do you? So so you're visiting for CFA? Is there a particular thing you're interested in at Liberty or anything? Sports psychology. Whoa. We have. Do we have sports psychology here?
Yeah, we do. But it's mainly just a psychology degree, and you're taking like 4 or 5 different sport sciences classes, and then that's about it.
Is the goal like is the whole idea to like counsel like athletes on how to psych out their opponents or something? I mean, like, what exactly? I don't know. Okay, so any questions? Any questions? Not Top Hat related? Actual math questions? What's that? It's right there. It's not working. Well, of course it's not working. Why would it work? Let's see here. Oh, it's working. It's working for, it has worked for 14 of you. So for the CFAR, I'm going to call you Mrs. CFA. Miss CFA. Miss CFA. Top Hat is this inane thing we use to take attendance here.
It costs money.
There is a good chance, if you do come here, I feel like there's a decent chance we'll not be using it by the time you come here because there have been so much connectivity issues with it this semester. I feel like there's hope that we're going to abandon use of Top Hat.
Oh yeah.
Now you guys are like, we already paid $80 for 4 years of it. I know, but at some point in your life, you're going to buy a car, and that car is going to be horrible.
Not unless you're
I
smart.
already have a car.
All right,
Unless you're actually smart and don't buy a lemon.
but you don't know it's a lemon until you buy it. And then, so the thing is,
Unless you know how to look at a car.
unless you know how to look at a car. But I mean, come on, you guys are going to college.
So I can learn how to look at cars.
Really?
Yes.
Couldn't you have like just worked in a mechanic shop or something?
I have to.
It would have been cheaper. But I'm let me stop talking you out of giving me money. So my point to you is you need to learn that when you have a car that doesn't work, you don't just hold on to it and like try to fix it. Just get rid of it. Get another one. In the same way, we should think of Top Hat. It's a lemon. It doesn't work. We should get rid of it. Go to Canvas or something. What's that? Get rid of attendance points too. I'm sorry, that is a university policy. I can't change that. Yeah.
Since Thanksgiving's coming up next week, can we do like a potluck on Friday or something?
Can we do like a potluck on Friday? I don't know what that means.
Like we all bring in food and share.
You all bring in food and share.
That's a great idea. Have a math 121 Thanksgiving.
Math.
Thanksgiving.
I will take that under consideration. All right, so any questions about the homework?
Your email.
Yep.
Number 17.
Number 17 of which week?
12.
Week 12? All right, let's work it.
Are we in?
It is week 12, believe it or not. Yes. Number 17, is that correct?
17, yeah.
Oh, when did you even ask me about a hard one? This one's not that bad. So we have two. Where are you stuck? What to do, or just?
Do I turn that into my
How, yeah, I mean, I guess that's the question: is how do you solve it, right? So the way I would solve it is to divide both sides by 2, isolate the log. So we got log x is equal to 10 over 2, which is 5, right? And then how do you get rid of? How do you isolate x if you've got a log like that? You take the exponential of both sides, right? So we go e to the ln of x equals e to the 5, which gives me x equals e to the power 5. There you go. So that's, in fact, the answer. Well, for mine. Yours might be different, but...
It gave me 3 ln x equals 5. Got me equals 15, but it's still not the same answer.
Yeah, you're right. 15 over 3 still. I see. It may be that the answer is always e to the 5, no matter what numbers you have, because they have rigged the problem to always work out to e to the 5. Other questions? That's going to be funny when you fall on the floor. But it's going to be extra funny because I said it's going to happen.
He probably doesn't actually math quiz in his head too.
But what would be more funny, although dangerous for me in terms of my employment,
I'm just gonna sit down now.
would be if I just gave it a little kick.
Would you make me pay for the drywall damage?
I don't think you damaged this. This one's kind of
It
thick.
is an exterior wall. So
Yeah,
You're
it's kind of.
private house, usually you can break that wall.
Yeah. Let's try it.
Done it.
I mean, you can try it if you want, but
As long as you're not
I
stuck
didn't
behind
tell you to do it. But I will tell you this:
Sorry.
if you get this whiteboard marker on this paint,
It won't come off.
yeah, it won't come off.
it. Ooh, let's do it.
No, I don't feel like it at the moment. I have children though, so you can figure out how that happened. Okay, other questions? Not related to Potluck Friday, connectivities with Top Hat, like actual math questions, other math questions. So point of order, I think like a smart use of money would be to print out your homework. Because then you can work on it and you have a record of what you did, you know? This is what I do anyway. I do know it costs a couple bucks. Probably not more than the cost of a meal at the moment though. Yep. Which number?
Oh, I just have a question regarding the next homework.
Uh-huh.
So the material we learn next week is what homework?
That's homework.
Do after break.
Due after break, but yeah, so I'm actually going to get started on that material today here once you guys are done with your questions. So, yep.
We have one that's due on Saturday, or tomorrow.
Yep, there's one due tomorrow. Yep. So other questions? We can do number 24 if I haven't done it. I don't know if I did or not. I don't think I did. I did?
No, you did.
I don't, as I guess, I don't think I did. So let's do 24. So example 2, which is number 24. I will say this, I think I've done all the different problem types at this point, so like nothing should be terribly surprising. You can solve all the problems that you'll come up against, I think, with pretty much the tool set that we've looked at.
Do all of us have the same first question for everything, and then if we get it wrong,
I mean, they're usually randomized. I'm not sure how they're randomized, but this should at least be similar to your problem 18. I mean, 24 rather. Okay, so First thing to do here is to rewrite this as log base 8 of x plus 3 times x plus 6 equals to log base 8 of 18, right? And then, let's see here, we can take both sides to the 8, right? 8 to the log 8 equals 8 to the log 8, right? Those are inverse functions. They cancel out. And what do we get? No, oh, no logs. Just x plus 3 times x plus 6 equals to 18. Right. You got. Unlike some of the other problems we had before, where we had a number on the right-hand side but only log on the left-hand side, this time we've got logs on both sides. So you could, if you want to, rather than doing raising both sides to the exponentiating both sides base 8, you could just use the one-to-one property of log 8 if you want. You could just say, well, this implies that. That would also be a legit step. Now what? Multiply it out, right? So we got x squared plus what? 3 plus 6 is 9x. Plus 18, right, equals to 18. Oh, well, that's nice. So x squared plus 9x equals to 0. And I think this one we should be able to solve, right? So factor x out. X times x plus 9 equals to 0. So what are my solutions? So we get x equals to 0 or x equals to minus 9. Right? Now, 0 is, if we plug 0 back in, right? We get log 3 and a log of 6, that's fine, right? So x equal to 0 is fine, but how about minus 9? Notice that that would give us like log of 3 minus 9, which would be log of minus 6, right? Which does not exist, yeah? So this is extraneous. As I told you guys before, if I was to be a rapper, I would call myself extraneous G. My tagline would be, I'm not even in the solution set. So, I feel like that. I'm not even in the solution set.
Boom.
That's right. And then I would drop the mic. Yes, go on.
If we had this
Like so.
question, but instead we were at.
Go on.
If we were given this question, but instead we were asked.
That only worked once.
If,
Go on.
if we weren't asked to solve it,
Uh-huh.
but we were asked to give what you have written in blue first, would
Yeah.
they word it as in simplified the equation?
Oh, yeah, we can talk about, there are other problems that are about simplifying. That would be, I usually say something like that is like collapse the logarithms into a single log.
Is that how you would word it?
Yeah, I could word it like that, sure. For example, here, example 3, consider the expression below collapse it into a single logarithm. And so here's the expression we'll look at. We could have something like, here I'll make it a little bit tricky. Log base 3 of x squared plus 1/3 log base 3 of y plus 2. All right. Plus 1. All right. Oh, and here, one more thing. Minus the log base 3 of the square root of Bob. There you go. That's suitably ridiculous for today. What do you think?
Log base of x squared times
Okay, is it you say,
root of y.
yeah, log base 3 of x squared times, you say that's going to be the cube root of y plus 2.
Yes.
All right. And then I'll do the easy part. Divide by square root of Bob, right? And then we're still left with this pesky +1 out here. How do you make 1 log base 3 of something? That's what's kind of a little bit trickier. 1 is not 0. 1 is 1. I mean, my question to you is, 1 is equal to log base 3 of what? Oh, so put a 3 there. So I can rewrite 1 as log base 3 of 3. And so then the answer here would be log base 3 of 3 x squared cube root of y plus 2 divided by square root of the bob. So there are those kind of problems. I would call that a collapsing the logarithm problem. They're also expanding the logarithm problems, right? I think we worked one of those last time. Did we work the one with the u and the v in it? Okay, so here's another one, like expand to sum of logs of variables. So I could run up against something like, natural log of, the square root of x times y cubed divided by, z squared w. So I say expand to a sum of logs of variables, right? So then I'll do 2 steps, right? I do natural log of the square root of x plus the natural log of y cubed minus the natural log of z squared minus the natural log of w. But what is the square root? It's the 1/2 power, right? Yeah, so we get 1/2 ln x plus 3 log y minus 2 log z minus log w. So those are, I would say those are the sort of 2 common log simplification type problems, right? Either expand or collapse. Can we do number 30? 13 and 30. Now you guys are getting greedy. You said 13, you said 30. I guess I should take those and find the one in the middle. Oh, I thought we worked this one already. But 13, I think we've worked already. But I will work it again. Example 5, number 13. We have 2 to the x minus 1 equals 3 to the 2x. Or you might have something different but similar, right? How do you solve that? I would solve that by taking the natural log of both sides and then using the properties of logs, right? So property of logs is I can pull down the x minus 1. I can pull down the 2x. Right? And then what? What do I do next? What's that? Isolate what? La la la. It's working. Solve for x, right? So I'm going to put all my x's on the left-hand side. I got x log 2 minus 2x log 3 equals to log 2. So I add the log 2 to the other side. Then I factor x out. And that gives me x is equal to log 2 divided by log 2 minus 2 log 3. Could you write this answer as a fraction of natural logs? Can you collapse the denominator into a single log? How would you do it? So this gives me natural log of 2 divided by 3 squared, which is 9. So there's how you could collapse that denominator into a single natural log if you wanted. But anyway, this was already a perfectly good answer to this problem. So you guys also asked about number 30? All right. Let's see here. That's the one with the big T in it, isn't it? Oh, no.
Mine has,
Oh, it's different.
log W equals
Cool.
S.
Yeah. Yeah, this one looks different for different people. Let me show you what mine looks like. What example am I on?
6.
6. All right, example 6. Here we're up against solve formula. Solve the formula log A equal to log E minus big N log X for A. And then they give you, it's multiple choice, right? So you got some choices. So how would you, I mean, this, well, my problem is pretty silly. There's really just one step here, right? What can we do? Now, what does log mean unadorned? It's the common log, right? Base 10, right? So yeah, so I would just say, okay, so 10 to the log A is equal to 10 to the log E minus N log X, right? And that gives me A is equal to 10 to the log E minus N log X, yeah? Now, that is, I mean, that's not a good answer, really. That's not a good answer. In fact, that is not, is that one of the answers? No, that is not one of the answers. Okay, so it's not one of the answers. What does that mean in this kind of problem? If you don't have one of the answers, you got to do what? Yeah, or simplify your existing answer, right? So this, by properties of exponentials, this is 10 to the log E, right? Times 10 to the minus N log X, right? But if we have something to the minus power, well, first of all, what's 10 log E? This is just E, right? So we have E divided by 10 to the N log X, right?
Wait, so
Why do you have, go ahead.
why is E, oh, because is it negative there?
Because I've got 10 to the log E.
Why do you have to keep the log in there?
Yeah, but why isn't N just N over?
Why do I have to keep the N in there? Because, well, one more step here. So this is E over 10, right, to the log of X to the N.
Why do we keep the log in?
Why, how could I get rid of it?
Well, in the first equations, they all have log. If you collapse it to be log E divided by X.
Oh, hold that thought. We'll get back to that. So this, see, now we've got 10 to the log of something, right? So we just get the something out again. So we get E over X to the N. Now what you're starting to talk about is the better way to do this problem, all right? So that is one of the choices for my problem, right? So so the way I just did this was basically an amalgam of like laws of exponents and then using laws of logs to suck the N into the log like there, right? There's a better way to do this, which is just to do what? At the start of the problem, to simplify simplify the right-hand side using properties of logs, right? That's what I should have done, right? It would have been smarter if I hadn't just taken raise both sides to the 10 power, right? It wasn't wrong. I think technically speaking, this is a solution, but it's not the most simple solution, so it's not the best one. To find the best one, we should simplify this. That's log of e minus log of x to the n, right? Which then is log of e over x to the n, right? So once you have that, what happens? This implies what then? I'll write it again. We have log of a
Yeah.
equal log of e over x to the n. So take both sides, raise it to the 10, exponentiate base 10, right? And we immediately get a equals to e over x to the n. Is that what you're telling me? Yeah?
Yes.
Yeah. So we get the same answer, right? But I had to work harder for mine because I had to use, properties of exponential and some sort of common sense algebra moves, like if I've got minus power, it becomes the reciprocal. And then I still, at the end of the day, I still have to use that property of pulling the n into the log. Anyway, yeah.
With harder questions, for instance, like as to solve the formula, you'll still have to use that method, correct?
Well, I would probably, if I was smart and I asked a question like this on a test, I would include wording like solve the formula, simplify your answer. So if I have simplify your answer and you leave me as this is the answer, well, that's not the most simple answer. So you get partial credit, but not full credit, yeah? Something like that. Or I could play the game like we played last class with that other problem where they let u equal this and v equal that and make you write your answer in terms of u and v. See, that's a way of like forcing simplification into a certain pattern without writing a cumbersome sentence saying things, It's just kind of a sneaky workaround for forcing students to write answers a certain way. Other questions? All right, so next topic then. And so I think we are near the end, right, guys? It's getting late in the semester here. I think if I have to remember, well, I don't take my word on this, but I think what we have left to do is to study like equations of circles. All right, equations of circles, systems of equations. All right, like how do you solve 3 equations and 3 unknowns, that sort of thing. And man, I don't remember what else. That might be it. There are a couple of topics I was toying with putting in this course, and I'm not sure what made the cut. Because I do try to leave a little bit of time at the end of the semester for you guys so you can review for the final, because it's important to me that you go back to the beginning of the course and fix all the stuff you got wrong, right? So part of the reason that I have, and like this material this is week 13 homework I'm now talking about, right? If you look at it in the book, it's what? It's section 4.6, I think. 5.5, where is this homework problem from? Oh no, it's worse than that. So my title's misleading, actually. If you look at the homework problems themselves, ID 2.22, 2.27, these are actually from chapter 2, section 2, right? This is from forever ago. I skipped over this section. The reason I did that, it was purposeful, all right? So let me show you why. Because to understand the equation of a circle, we need to go back to a basic algebra skill that we still need to work on, all right? So let's talk about that. So what is a circle? What's the definition of a circle? How would you define it? Pi? No. Okay. So here's what I would say. Definition. A circle of radius. Oh, come on. Stupid marker. Radius, I'll say big R, centered at x naught, comma y naught, is the collection of all points x comma y which are distance, God, good grief, I can't spell today, distance r from x naught, y naught. What's the distance formula? Do you guys remember? What is the distance from x naught, y naught to, do you remember the formula for this? What's the distance from x comma y to x naught comma y naught? How do we calculate that distance? You guys remember? So if I have the, if I have the plane and I've got this point here, x comma y, right? And I've got this center point over here, x naught comma y naught. How do I calculate this distance right here? What's the formula for it? So we could draw a right triangle, right? In here, like this. And we could look at the change in x here and the change in y here. The change in y would be y minus y naught for my points. The change in x would be x minus x naught. So remember, the distance here, squared, is the change in x squared plus the change in y squared, right? That's the Pythagorean theorem. So the distance formula here would be the square root of x minus x naught squared plus y minus y naught squared, right? Now what is this circle? The circle of radius r centered at x naught, y naught. It's the collection of all x, y, which are distance r, right? So we're looking for all x and y such that this square root of this mess, right, is just equal to r. Now, do you guys like square roots? Yeah, me neither. So in order to get rid of the square root and to have a nice equation for the circle, we square this equation. So the circle of radius r, all right, centered at x naught comma y naught, is equal to its x comma y such that x minus x naught squared plus y minus y naught squared equal to r squared. So there you go. That right there is, for our intents and purposes, the definition of a circle. We can define the circle by the equation which it solves. Right? I mean, I defined the circle to start with by a what? By a sentence, right? The collection of all points equal distance from a center point. But this is, pragmatically how we look at it, all right? Yep.
What's a knot?
Oh, that's just a label. You could put, if you don't like sub knot, yeah, you could put x1, y1 there if you'd rather, if you don't like the sub knots.
So knot is just a knot.
Just a label. Yeah, just label. Like, you could, at some point later, if you have a child, you could name them like Kendall Subnot. Yeah.
I like that.
Yeah.
I think I'll do that.
People usually do junior, I guess, but. Hey, is there a female junior? Junior Rita? I don't know. I mean, I associate with junior like male, right? Am I wrong? I've never run across like here's my daughter, Jessica Jr., like I haven't experienced that. Have you?
Yeah.
I mean,
Women are smart, let that happen.
are you saying people with the name Junior aren't smart?
I think it's the parents.
I'm not smart. I'm sorry. My dad was a junior, but makes me feel better. He's actually not smart.
There is some history about Junior here. That is true. Let's see here. Where are we? Example. Okay, so. Now that we have this definition, let me give you some examples that put it into practice, and let's graph the circle, right? Example 7. Suppose I've got a circle that's got center right here and goes through the origin, all right? And the center is, let's say, 2 comma 5. All right, so you got the center of the circle is 2 comma 5, and you're also given that the circle goes through the origin. Can you find me the equation of this circle? That's equation, guys. You know my abbreviating ways. So I think really what we have to do is figure out what's the radius of the circle, right? How do you do that? So the radius should be this distance, right? The distance here. So how do you find the distance to the origin of a point? We do r is the square root of 2 squared plus 5 squared, right? So that point is equal to the square root of 29 from the origin. And so, hey, that's all we need. We go back to our definition, and the equation of the circle, it's going to be x minus 2 quantity squared plus y minus 5 quantity squared equals to r squared, which in this case is 29. So there you go. Let me take this example and raise you a question. Here's my question. Is the circle above the graph of a function?
No,
Why not?
because it's not one-to-one.
Because it's not one-to-one. A function can, yes. Yes, it fails the vertical line test. That is exactly correct. So if we look at this, right? For example, this vertical line right here, it hits the circle here and here, which means it fails the vertical line test. Here's my follow-up question. Is the circle the graph, is the circle round? Is the circle the graph of 2 functions?
Asking the real questions.
And if so, what are their formulas?
Yes.
I heard a yes. A yep. Okay, what are the formula for the function?
I know it's a yes.
You just know it's a yes? All right. So let's solve for y. So we've got y minus 5 squared equals to 29 minus x minus 2 squared, right? Which then gives me y minus 5 is equal to plus or minus the square root of 29 minus x minus 2 squared. So we get y is equal to 5 plus or minus the square root of 29 minus parentheses x minus 2 squared. And so what's going on here is very simple. You've got these equatorial points where they match up, right? And the bottom of the circle here, this guy right here, that's y equals to 5 minus the square root of 29 minus x minus 2 squared, right? And that is a function, right? This bottom half of the circle passes the vertical line test, right? Agree? How about the top half? Well, the top half also passes the vertical line test. The trouble, of course, is when you put them together, right? You can't have both and have a graph of a function. But if we expand our thinking and say we're looking for things that are formed by the union of 2 graphs, well, then you can get a circle. But going back to the comment, you're right. Both of these functions fail to be one-to-one. Like neither of these functions that I've graphed, the red or the blue, is injective. It's, oh, excuse me, injective. What's that? Oh, excuse me. Wipe that from the record. Excuse me. Neither of these are one-to-one. We don't know what injective means. It just means one-to-one. Let's see here. I'll stop. So that's 5, 2. Wait a minute. 2, 5. Yeah, sorry. let's work another example. Now, you might at this point be like, I thought you said this was going to help us review for the final, or you were sort of, the final, the final isn't cumulative? It's something I would never say because it is incorrect. My goal in the final is to have one problem that somehow, is the final is just one problem, and that one problem has every single possible thing we've done this semester.
What?
What? No? Yeah, please no. Example 8. So consider x squared plus 4x plus y squared minus 8y equals to 0. Let me make it equal to, not 0, but let me make it equal to like, I don't know, 300 there. The question is, show that this is a circle. Find its center, find its radius. Equation has solution, which is a circle. Find its center and radius. Okay, so let me warm up the projector while I'm doing that. Oh man, I just covered up the definition of a circle. That's bad. So what am I going to do here, folks? I've got x squared plus 4x plus y squared minus 8y equals to 300. Something's going on here. All right. So what I do, you remember this? I'm going to take this. I'm going to put x. I'm going to add 2. I'm going to square that thing. And then I'm going to subtract 4. What did I just do? That's right. I just rewrote the first 2 terms by completing the square. And then I'm going to take the next 2 terms and I'm going to complete the square there. This time I got y minus 4 squared. Square of 4 is 16, so I have to subtract 16. Right? This is all equal to 300.
Minus 20.
Right. Oh, minus 20? I think I add 20, yeah? So I get x plus 2 squared, but your heart's in the right place.
I was trying.
You're trying to see it. Y minus 4 squared equals to 320. And then if we use our imagination, we can see that 320 is really the square root of 320 squared, right?
Yes.
So recognize the center. I keep putting, I don't know, my spelling is becoming British today or something. Yeah, here we go. There.
Yeah. That's how I spelled it.
Ugh.
I would have thought you were
Sorry.
correct.
There we go, center. Minus 2, comma 4, right? Radius. R equal to what? Square root of 320. So there you go. There is probably, there should be anyway, a few problems at the start of your week 13 homework, which are about these circles like this, yeah? Ooh, then we've got word problems. Ooh. Word problems, and then systems of equations. Now, let's look at something here in the time that remains, because I'd like to talk more generally about what equations look like, all right? So here it is. So I'm using Desmos, which is, you know, again, a really nice free visual, you know. Let me get rid of those. So which one did I just do? I did x squared, what was it, plus 4x plus y squared minus 8y equals to 320, is that right? 300? So I can't see it at the moment. Let me zoom out. Behold, circle. So I want you guys to notice something. This is just, I may have to tilt it a little bit. Oh, you got it. Okay, cool. Listen, this is part of a more general story, which is if you have something like ax squared plus bxy plus cy squared plus dx plus ey plus f equals to 0. The solution set of things like this are called conic sections. So circles are a special case of this, but there are also ellipses and hyperbolae and lines, and they can be really, really interesting. Let me show you. Oh, man. Oh, man. Fine. All right, fine. Here we go. So we've got a x squared plus b xy plus cy squared. And I'm going to skip the last part, okay? Plus d, I'll just put that equal to, oh fine, plus what? Plus dx plus e y plus f equal to 0, let's say. And let's see what happens when we move these sliders around. See that? What's that? So for the most part, we're seeing hyperbolas, which just look like these. Let me stop animating and just pick some specific values here. So if I put a equal to, say, 2, b equal to this, c equal to 1, maybe, but d equal to 0. Where is, oh, it's in there, isn't it? See that? So that's an ellipse, right? An ellipse is a circle which is kind of smushed, right? And but this is an ellipse which is what? It's not like parallel to the coordinate axis, is it? So that's the reason for this is that b term, that xy term, means that speaks to a rotation. So to really understand this, you have to go on in the math major and take something called linear algebra. We learn the tools and tricks that you need in there to make sense of it. Even if I just change b, we can change it from like an ellipse, see this, to like a kind of more of a ellipse the other way, and then at some point it's going to break and become a hyperbola. See, that's a hyperbola, like that. I can, anyway, I just thought I would be fun to play with these for a second here and just kind of show you this kind of equation. Yes, it gives you circles, but more generally it gives you ellipses, hyperbolas. And that's pretty much it. These are all conic sections because, do you know what a cone is?
Yeah.
A cone looks like this, actually. When we say cone, we're actually talking about a double cone. So if you think about a double cone, you can either cut it, if you cut it vertically, you get like the hyperbolas. If you take a horizontal slice like this, you can get an ellipse. If you cut it just straight up horizontal, you get circles. So conic section. Section means cut, like a butcher sections a cow for you, for example. Anyway, that's it for today, guys. Happy CFOT to you all.